Hello friends, today I'll start with the embedded system lecture only. In case of the embedded system, I have already discussed the introduction to the embedded system and how many types of embedded systems are there, what are the advantages and disadvantages. This thing I have already discussed. Okay, 8051 is the another part of the embedded system, which is the processor. Okay, so now come to the architecture of the 8051. Okay, so architecture in exam question, it is very common to come this kind of the questions and right architecture being diagram. So it is little bit difficult to remember such kind of the architecture. Okay, so I try to explain like this so you can easily understand, you can easily remember what is the architecture of the 8051 microcontroller. Okay, so 8051 microcontroller architecture design. Okay, so in case of the any kind of the microcontroller, okay, either it may be processor or it may be microcontroller. Normally, and that CPU, this is the one of the part of the microcontroller, one of the biggest part of the microcontroller, and one of the you can tell is the heart of the microcontroller. Okay, CPU, central processing unit. So you have to remember CPU here. Okay, CPU. Okay, central processing unit. Okay, so what is the function of the CPU normally? So I will discuss this in later also, so I'm not writing the function and I'm just telling what is the function of the CPU here. Okay, CPU means central processing unit. Okay, so when you think about the microcontroller, so microcontroller is one kind of the processor. Okay, so if you think about the processor, microcontroller normally think about the processor. Then processor means it process something, whatever processor, whatever platform you need. Okay, based on the requirement, this thing can be done by the CPU only. Okay, whatever performance you require, this thing can be done by the CPU only. Okay, that is anything. Okay, central processing unit. Okay, it can store a lots of data. It can store a lots of data in the form of the register. It can perform different kind of the mathematic operation and also lots of program. If you want to process something, okay, you need to program that thing. Okay, you need to program the program the code. Okay, so for that you need to write the code. So whatever if you write a code and that code should be executed, so everything will be done by the CPU only. Okay, so this is the main thing. Okay, I'm writing here. It can program. Okay, register different function mathematics. Okay, this thing can be done by the CPU only, right? So you need to first draw the CPU. Okay, so whatever performance, mathematic performance or the any program that is executed by the CPU only. Okay, so next is the and different registers are also available in CPU. And next is the I'm writing here on chip ROM. Okay, then RAM. I think you know about the ROM and RAM. Okay, so ROM means read-only memory. You have to store the data permanently in case of the ROM, and RAM is the random access memory. You can store the data temporarily in case of in RAM. Okay, so normally permanently storing data permanently in ROM. So size of the ROM should be always higher than the size of the RAM. Okay, in case of the computer also you can see the ROM size is larger than the RAM size, and then it is typically storing the temporary data inside the RAM, random access memory. Okay, so as this the size is more, so the size is 64K, here it is 128 byte. Okay, the on-chip ROM, what it is meaning? These are the inbuilt inside the 8051 microcontroller. If you want to store more amount of the data, so for that you need to connect the external memory. Okay, so this is the on-chip ROM. This is the RAM. Next, so normally in case of the ROM, it store program memory data. Program memory. Okay, and RAM store the data. Okay, so normally the whatever program you have written for the particular application, okay, this program will be permanently stored inside the ROM. Okay, but you are taking the data, okay, and that data you need to store for some time. Okay, you need to store the data for some time. That data you can store under the RAM. Okay, lots of registers are there. You can store the data, okay, inside the RAM. After that you can pick those data for doing the some operation, okay, and for operation, and after the execution of the program, these along with the data and program, that will be stored inside the ROM. Okay, so this is data memory, this is the program memory. Okay, these three I have written first. Okay, so you can easily remember. This is processing for storing something. ROM and RAM are required, and this is for operation, doing some operation. Okay, so now, in enter system, we need some wire to transfer address data and the data. Okay, this thing you need to carry through different channel. Okay, so for that there is a control bus. The collection of wires. Collection of wires. Okay, so this can include data bus and address bus also. Data bus carries the data only, and address bus carries only the address location. Okay, suppose you data have normally the data bus includes 8-bit and any kind of the control bus. Okay, it can carry 8-bit data, 8-bit information, as well as the 16-bit information also parallelly. Okay, so the data bus, the 8-bit data will be transferred through the data bus in different portion of the 8051 microcontroller, and that 16-bit address data, that will be transferred through the address bus in different location of the microcontroller. Okay, but data bus, okay, data bus. What is the function data bus? It carries data from peripheral to peripheral. Okay, but the address bus that carries the information from CPU to memory. Okay, address bus, CPU to memory, and but data bus, information will transfer through the data bus from peripheral to peripheral. If you connect the external device, okay, if you connect the external device with microcontroller for doing some operation, so from one external device to other external device, that will be transferred through the data bus. Okay, so you try to remember data bus contain only the 8-bit information, but the address bus contain the 16-bit information. Okay, so this is not under the architecture, just for understanding I am telling. So what is the control bus and how many bits are there, and through the data bus which type of information, what is the source and location for data bus, this I have told already. Okay, control bus. So next is the IO port. I0, I1, I2, I3, or you can tell us a port 0, port 1, port 2, port 3. IO port is 8-bit. Total 4 parallel 8-bit channels are there. So normally if you connect the external peripheral, that will be connected through these 4 channels. Okay, I0, I1, I2, I3. But what are the different? But some different function is there. between I0 I1 or I0 I2 I0 I3, this I will tell later. Okay, but this IO port means input output port. If you want to connect some external device, so that time same port can be act as input port or same port can be act as output. Input port means so you are giving some information to external. This is the input port. Output port means you are collecting some information from the external. Okay, this will be the output. So that's why the name is input output port. If you want to, so only not only the microcontroller is a part. If you want to design one application, okay, you need to connect some other components along with the microcontroller. Okay, for doing some operation. That's why you need to connect the device through the input output port. Okay, so this thing. Okay, so one by one I'm going to check the main part. Which how can you remember the architecture? Okay, next is the serial communication. You could transfer the data in external device through serially, not parallelly, through serially. You transmit data through the TXT and receive data through the RXT. So this is about the serial communication, TXT and RXT. Okay. So next is the timer and counter. Serial communication is a little bit difficult to remember that part, but the timer and counter, I have already told the microcontroller it can perform the specific task within a specific time. So timer and counter, this is also one of the important part for microcontroller 8051 microcontroller. Okay, so the timer and counter is also one of the part. Okay, so there are the two timers. Okay, T0 and the T1. Okay, this is also 16-bit. This is also 16-bit. Two timers are the T0 and T1. So the same timer will be act as a counter. So for that you need to set different the different bit for counter. Okay. So 2-bit, to T0, T1, 16-bit, 16-bit. Okay. IO ports are 8-bit. Okay. But the timer and counter, these ports are these things are 16-bit only. Okay. So for activating the timer and counter function, okay, for doing timer means you need to do this task within this time, okay, and you need to count the sequence, okay. So for that you need a oscillator, okay, you need to give a frequency. The time is related to frequency only. So how can you give generate the frequency? By using the oscillator only you can generate the frequency. You will give the frequency, accordingly you will get the time. Okay, so the processor CPU is doing some operation, right? Some processing. The function of the CPU is doing some operation of processing. Okay, so that's why the oscillator that will be connected to the CPU only. Okay, which can give 12 megahertz. So different oscillator, and you can use also 16 megahertz oscillator. Okay, so this kind of the oscillator you can connect. Okay, either it is in on chip or it is also external. You can connect the externally, or you can inbuild inside the 8051 microcontroller. Okay, what is the task? This task is to generate time frequency for doing the timer and counter operation. Okay, so I think you can easily remember this CPU, the CPU, ROM, RAM, control bus, input output port. Okay, only this is little bit difficult, and the timer and counter, because 8051 means timer and counter, this component should be there, and for timer and counter you should have the oscillator. Last part, when you connect the external interface, I have told that input output port, this is used to connect the external interface. Okay, so there is a one term that interrupt. Okay, there is one term that is interrupt. Okay, so there are the total 5. Okay, total 5 interrupts are there. This will discuss elaborately later. So two external interrupt, Okay, two timer interrupt and one serial communication interrupt. So by name you can easily understand that what that this interrupt means. So you are doing, so the CPU is doing executing one program, okay, that is related to one function, but at the meantime it will get the information. The CPU need to do the other program, okay. So in the whose priority is more than the current program, okay. So CPU stop the current program and it will store its location to the program counter stack pointer, and after that it will execute that priority wise the program, okay. So the interrupt signal, give interrupt signal with a priority, okay. Okay, that key you stop CPU had to stop, has to stop the current program. It had to execute the previous the interrupt which this the priority wise program it has to execute, okay. So accordingly they have to give the signal interrupt. This is a subroutine of program. So in the main program you have to need to write another program. So the memory location will be directly go to the that point. Okay, the program counter point that corresponding program. Okay, this will discuss later also. So external interrupt means when you connect the external device and your program is the priority wise program is associated with your external device, then external interrupt is activated. Okay, and timer interrupt, if any program is related to timer which is the highest priority, then timer interrupt will give the signal to CPU. And serial monitor means, so for is any program is associated with the serial communication, if data is to transfer through the serial monitor, so and it is the highest priority, then the serial communication interrupt will be activated. Okay, so this interrupt portion will discuss later only. This is about the entire architecture of the H251 CPU, ROM, RAM, 64K, 128 byte, data bus and control address by data bus 8-bit, address bus 16-bit. These two timers, 16-bit timers are there. 5 interrupt signals, 4 8-bit parallel input output ports, and 2 serial communication signal. Okay, 2 external interrupt, 2 timer interrupt, and 1 serial communication. Now, so this interrupt are related to these 3 port only: external interrupt, sequential interrupt, timer, and our interrupt. Okay, so for timer and interrupt, you need oscillation for generating the frequency and time, and CPU is the heart of the microcontroller. Okay, so next class I will start with the IC and pin diagram of the 8051 microcontroller. Thank you, and please like, share, and subscribe my channel.